Now let us take few more questions on design and analysis of algorithm. Give the recurrence relation of divide and conquer. So we'll see the general recurrence relation of divide and conquer. For example, if Tn is the relation, then it will be broken down into Tn1, Tn2 till Tnk, and then we have a function f. For example, if you talk about merge or etc., then this will boil down to some constant Tn by 2, and then you can have some function f, say this one. So this is the recurrence relationship of divide and conquer. The basic idea is to divide the problem into sub-problem and then to compute. Write the algorithm for iterative binary search. Binary search, iterative. This is the algorithm of binary search. In this, what we are trying to do is, first we'll start with low equal to 1 and high equal to n. Okay. Then when while low is less than high. See, low is less than high at a point where high becomes low. That means you have carried out the whole process. So we will check for low less than high, and then we will compute the midpoint of low plus high by 2. That is, for the first time it will be n plus 1 by 2. The mid one. Mid value will be there. Now x will be checked for this a mid. Means the mid value will come from here, and a, this is the array, this array. So the mid value will, or the array subscript will be mid, and a mid will correspond to that mid value. So if x is less than a mid, then what we are going to do is, if this is first low, this is high, and we have computed the mid. Okay, this is mid. So if x is less than a mid, means this one, we'll take high now as high. High means mid minus 1. Just less than this mid minus 1. So it will be mid minus 1. Now for the next season or next iteration, we'll only carry on with L and mid minus 1. But if this mid, if the value x which is coming, which need to be searched, is greater than this mid, then we'll change the low to mid plus 1, because for mid already being checked, so we'll go for mid plus 1. So low will be mid plus 1, high will be, or high will be, and we'll not even touch this, we'll go along with this. There is one more case that we'll check. If a mid equal to x, then we'll just say, there was one case also you are going to write, that if this a mid equal to x is equal to a mid, then you will say success. Okay. What are internal nodes? The circular node is called the internal node, or the internal nodes which are internal in the formation. So circular node are generally known as internal nodes. Describe the recurrence relation of merge sort. So this will be, say, we can have a, say a2 or a1, anything you can write. Tn by 2 plus n. This is the recurrence relationship of merge sort. So if the time for merging operation is proportional to n, this is time t, this is proportional to n, then the computing time of merge sort is described by the simplest is this: a t n by 2 plus some c or n something. What is meant by feasible solution? Now this is a very important question. Feasible solution. If you are given n inputs, you are required to form a subset such that it will satisfy certain constraints. Such a subset is called a feasible solution, right? Satisfying the constraints, you have to find the solution. This subset is known as the feasible solution. Write any two characteristics of greedy algorithm. Greedy algorithm always searches for the local minimum. So whatever is closest and the highest or lowest, it will take that. So the two characteristic is, to solve a problem in an optimal way, we construct the solution from the given candidates first of all. As the algorithm proceeds, first to solve a problem, we construct a solution from a given set of candidates. This is the first case. Then as the algorithm proceeds, two other sets get accumulated among this one set. This contains the candidates that have already been considered and chosen, while the other set contains the candidates that have been considered rejected. So you start with one set, then you will have two sets, one which is considered or which was not considered. Define the optimal solution. What is an optimal solution? The feasible solution which we have just seen, either it maximizes or minimizes the objective function. So the feasible solution which either maximizes or minimizes the objective function is known as the optimal solution. Next is the knapsack problem. What is the knapsack problem? See, it is related to a thief. A thief has a bag, and now he wants to place the items which are available in such a manner that it maximizes the theft. So, a bag or a sack is given capacity, and are given. So each object has some weight. These are objects; they have some weight with some profit pi. So fraction of the object is considered as xi between 0 to 1. So if a fraction is 1, then the entire object is put into the sack. When we place this fraction into the sack, we get the weight and this profit. So the knapsack problem is to maximize the item. First of all, to choose the best items that will fill in and that will maximize the profit. Define the weighted tree. A directed binary tree for which each edge is labeled with certain weight, real number. This is called a weighted tree. So this weight can be anything, It can be the distance from one point to another, or there are various real life problems which can be represented by weighted tree. What is the use of TVSP? TVSP. In places, this TVSP is in places where the loss exceeds the tolerance level. Boosters have to be placed. So, given a network and loss tolerance levels, the three vortex splitting problem is to determine this is three vortex splitting problem. TVSP stands for three vortex splitting problem. So, given the network and loss tolerance level, the three vortex splitting problem is to determine an optimal placement of the boosters. This is the use of TVSP. What is the greedy choice property? Greedy choice property. See, the first component is greedy choice property is a globally optimal solution that can arrive at by making a local optimal choice. So we have to first, or the algorithm first, make an optimal choice, local optimal choice. Then the choice is made by greedy algorithm. It depends on choices made so far, but it cannot depend on any other future choices on the solution to the subproblem. And it progresses in top-down fashion. This is the greedy choice property. What is a greedy method? Greedy method is the most important design technique. It makes choice that looks best at that particular moment or instance. So a given, say, n inputs are required as to obtain a subset that satisfies some constraint. That is the feasible solution. So greedy method suggests that one can devise an algorithm that works in a stage considering one input at a time. Next is, what are the steps required to develop a greedy algorithm? First, we determine the optimal substructure of the problem. When we develop a recursive solution, then we prove that any stage of recursion, one of the optimal choice is a greedy choice. Thus, it is always safe to make a greedy choice. Then we show that all but one of the subproblems induced by having made the greedy choice are empty. Then we again develop a recursive algorithm and convert it to the iterative algorithm. What is active selection problem? If you have n tasks, task will given with if you're given n tasks with starting time, say Si and finishing time Fi. Si is starting time, Fi is finishing time. So feasible solution is that the task should not overlap. An optimal solution is that the task should be completed in a minimum number of machine set. This is activity selection problem. Write the specification of TVSP. This is the specification. First of all, we have VEW. This is a T. This is a weighted binary, weighted directed binary tree. V is the vertex, E is the edge, and W is the weight. And W is commonly denoted as Wij, which is the weight of the edge. What is meant by tolerance level? Tolerance level. The network can tolerate the loss only up to a certain limit, which is known as the tolerance limit. When is a task said to be late in a schedule? A task is said to be late in any schedule if it finishes after its deadline. Else, we say that task is early in the schedule. Define the feasible solution for TVSP. See, given a weighted tree, we have already seen this tree, vertex, edge, and weight, and we have a tolerance limit. So any subset of x or v is giving a feasible solution if d t by x is less than equal to this tolerance limit I. Define optimal solution for TVSP. An optimal solution is one in which the number of node of x is minimized. Define the forest. What is the forest? Collection of subtrees that are obtained when a root node is eliminated is known as forest. Very important. Collection of subtrees when root node is eliminated. What does job sequencing with deadlines mean? If you are given a set of n jobs and each job has deadline d such that di is greater than equal to 0 and a profit pi such that pi is greater than equal to 0. For job I, this profit pi is earned if and only if it is completed within the deadline. processing the job on the machine is for 1 unit of a time, only one machine is available. Then we have defined post-order traversal. In order in which we are talking about TVSP. TVSP visits the node of the tree is called the post-order traversal. There are other traversals also in tree, which is post-order traversal. The route is traveled at the last. Write the formula to calculate delay and also write the condition in which the node gets splitted. This is to calculate the delay in which this maximum of the values dv and wuv is checked. The condition in which the nodes get splitted is this value is greater than the tolerance value, and also this du gets to is set to the 0. Write the general algorithm for greedy method control abstraction. This we have already seen, I guess, but still we'll go to it. This is the greedy method control abstraction. Solution is equal to 0 from, this is a for loop from I to n. We select A from A, and if feasible solution X is feasible solution X, then solution will be union of solution X. Otherwise, we'll retain the solution. Define the optimal solution for job sequencing with deadlines. Feasible solution with maximum profit is the optimal solution for the job sequencing with deadlines. What is the difference between greedy method and a dynamic programming? Greedy method and dynamic programming. In greedy method, only one sequence of decision is generated, but in dynamic programming, many number of decisions are generated. Greedy method, it does not guarantee to give an optimal solution always, but dynamic program will give you always an optimal solution. Define dynamic programming. Dynamic programming is an algorithm design method that can be used when a solution to the problem is viewed as the result of sequence of decision. Next question is, what are the features of dynamic programming? Optimal solution to sub-problems are retained. Optimal solution to sub-problems are retained so as to avoid the recomputing their values. Okay. Let me tell you again that there are certain ways and there are certain things which are repeated. So the optimal solution to these sub-problems, they are retained. We don't recompute them again and again. So decision sequences containing these subsequences that are suboptimal, they are not considered. It definitely gives the optimal solution always. What are the drawbacks of dynamic programming? Time and space requirement of dynamic programming is quite high, since storage is needed for all levels and optimality should be checked at all levels. Write the general procedure of dynamic programming. The development of dynamic programming algorithm can be broken into a sequence of 4 steps. General procedure of dynamic programming. First is to characterize the structure of an optimal solution. Recursively define the value of optimal solution. Compute the value of optimal solution in the bottom-up fashion and construct a optimal solution for the computed information. Define principle of optimality. This states that an optimal sequence of decision has the property that whenever the initial stage of decision must constitute an optimal sequence with regard to stage resulting from the first decision. This is the principle of optimality. So these were a few more questions on your analysis design of algorithm. Thank you so much.